Hey there, and welcome back to the Deep Dive, your shortcut to truly understanding complex tech topics without all the usual information overload. I'm your host, ready to jump into another exploration with you today. Today, we're diving headfirst into the Avi Cloud Foundation. Think of it like pulling back the curtain on some really critical concepts, stuff that's non-negotiable if you're working with modern cloud networking. Our mission, well, it's to extract those golden nuggets of knowledge. We're focusing on high availability, smart scaling, solid security, and, practical diagnostics. We want those aha moments for you.
Absolutely. And this isn't just abstract theory we're talking about. These concepts, they have huge real-world significance. Understanding how to make things resilient, how to scale automatically, how to secure connections properly, and troubleshoot well. I mean, these are the details that make a cloud environment robust and efficient. Get these right, and it's a whole different ballgame compared to constantly fighting fires, dealing with downtime, or performance issues. It really boosts your operational game.
Couldn't agree more. And the source material for this deep dive is pretty unique. We're actually using insights from practice questions for the 6V0-22.25 exam. Now, hold on. This isn't going to be an exam cram session, promise. But using that lens is super valuable. It tells us these are the core problem solution type things you really need to know in a production Avi setup. Just for context, that exam's about 90 minutes, maybe 65 questions, 70% to pass. So it's focused on the essentials. Let's leverage that perspective and get into the good stuff. Okay, first principle, reliability. In cloud infrastructure, it's just...
Fundamental, right.
If your management plane hiccups, everything's at risk. So talking about Avi controllers, the brains of the operation, basically what's the absolute gold standard, the best practice to keep them available even if a node fails, especially in, say, a critical production VCF environment.
Yeah, that's foundational. For real availability, particularly in production VCF, the answer is clear. Deploy a 3-node controller cluster. And crucially, it needs automatic leader election. That's not just a suggestion. It's really the core architectural choice for resilience.
A 3-node cluster. Okay, why 3 specifically? What's the magic in that number, and what does automatic leader election actually do in practice? Because I've seen setups try to cut corners with 1, maybe 2 controllers.
Right, and that's asking for trouble.
Yeah, and then, bam, major downtime during something simple like maintenance.
Exactly. So the controllers, as you said, they manage everything for the service engines, configuration, operations, the lot. In production VCF, they have to be highly available. A 3-node cluster gives you what's called quorum. If 1 node goes down, hardware failure, network issue, whatever the remaining 2 nodes can still talk, agree on the state of the world, and automatically, seamlessly elect a new leader. This means the control plane just keeps running. No disruption to your services, no loss of management. It's designed for fault tolerance.
Okay, quorum. So 2 nodes aren't enough for that.
Well, with only 2, if 1 fails, the remaining 1 doesn't know if the other failed or if there's a network split. It can't safely take over. It loses quorum. 3 nodes solve that ambiguity. And yeah, single controller. Obviously no HA there. And just relying on something like VMware DRS anti-affinity rules.
Yeah.
That helps keep VMs apart, but it doesn't provide this kind of active stateful failover for the Avi control plane itself.
Right, so it's proactive resilience built in, not just reacting after the fact.
Precisely. It's fundamental to the design.
Got it. Okay, so control plane resilience, check. But traffic isn't static, right? Cloud is all about dynamism. Loads go up, loads go down. So next challenge. How does Avi smartly and automatically scale its service engines, the workhorses, handling the traffic when things like CPU or memory usage spike? What needs to be configured for that magic to happen?
This is where Avi gets really clever with resource optimization. For that kind of dynamic automatic scaling, you need 2 key things working together. First, you need an auto-scale policy defined right on the virtual service itself.
Okay, an auto-scale policy.
And second, the service engine group that those service engines belong to. It needs to be configured for Elastic HA mode.
Auto-scale policy on the virtual service, Elastic HA on the SE group. Got it. How do those 2 play together? Why both? What does Elastic HA actually, enable?
Great question. They're symbiotic, really. The auto-scale policy is where you set the rules, the triggers. You define things like, okay, if average CPU across the service engines for this virtual service hits, say, 70% for 5 minutes, scale out, add another SE. Or if it drops below 30%, scale and remove 1.
So that's the brain setting the conditions.
Exactly. But the policy itself can't just create new service engines out of thin air. That's where Elastic HA mode comes in. Configuring the service engine group for Elastic HA basically tells the Avi controller, hey, you have permission and the capability to dynamically spin up new SE instances from the template or destroy existing ones within this group based on those autoscale policies.
Ah, so Elastic HA is the mechanism that allows the scaling to actually happen.
Precisely. Without Elastic HA enabled on the group, the autoscale policy is just rules with no power to act. You need both for the automatic scaling based on load like CPU or memory.
Makes perfect sense. And connecting that to the bigger picture, this automation is huge for efficiency.
Absolutely. It optimizes your resource use.
Yes.
You're not over-provisioned all the time. It maintains performance during peaks. And it does it without someone having to manually intervene constantly.
Like a smart thermostat for your app traffic.
That's a great analogy. And yeah, things like specific IPAM or DNS profiles or NSX edge settings, they're important for other network functions, but they aren't the direct triggers for this specific type of SE autoscaling.
Okay, clear. So we've got resilience, we've got dynamic scaling. Let's talk secure connections, HTTPS everywhere, obviously. But that encryption decryption is heavy work. When you set up HTTPS offload in Avi for a virtual service, which bit actually does that heavy lifting? Where does the client's SSL session terminate, and what presents the certificate?
Right, so when you enable HTTPS offload, the key player there is the SSL certificate and profile that's configured on the virtual service.
The certificate and profile, okay.
Yep, that's where the termination happens.
Yeah.
The client connects, the handshake occurs, the certificate is presented by Avi, and the traffic gets decrypted right there on the service engine.
And the benefit of Avi doing that instead of, say, the back-end web servers?
Oh, it's a massive difference. Two main things: efficiency and security posture. Efficiency-wise, SSL TLS processing takes a surprising amount of CPU power. By offloading it to the Avi service engines, you free up your back-end application servers.
The chef's analogy again?
Exactly. Let the specialized Avi SEs handle the dishwashing of SSL, so your application servers can focus purely on serving the application logic. This means better app performance, better scalability.
And the security aspect.
Well, centralizing SSL termination on Avi gives you a consistent point of control and visibility. You manage your certs there. You can apply consistent security policies related to SSL TLS versions, ciphers, and so on right at the edge.
Okay, so it's not things like the application profile or the health monitor that handle the actual crypto.
No, those have different roles. The application profile deals more with layer 7 behavior, how Avi interacts with the app protocol like HTTP. The health monitor just checks if the backend servers are alive and responding. The actual SSL termination, certificate presentation, encryption, decryption, that's all handled by the SSL TLS certificate and profile on the virtual service.
Crystal clear. Now, shifting gears slightly, but staying on security. Let's talk about security inside the network, that east-west traffic, server-to-server communication within the data center. When you deploy Avi service engines inside NSXT segments, and you need that fine-grained east-west security microsegmentation, how does the Avi and NSXT integration help enforce that? Which NSXT features are key?
Ah, good one. For that deep internal security within NSXT segments where SEs are running, you're typically looking at two primary NSXT features working together. Those would be distributed firewall rules applied to the segments where the SEs live, and SpoofGuard enabled for the SE logical ports.
Okay, distributed firewall, DFW rules, and SpoofGuard. Break that down for us. How do they combine to lock down that internal traffic? Because, like you said, east-west is often where threats can spread if they get inside.
Exactly. It's about creating multiple layers of defense right there within the network fabric. So the NSXT distributed firewall is, well, distributed. It enforces rules right at the virtual NIC of every workload, including the Avi service engines. This lets you create really granular policies. You can say, okay, web servers in this segment can talk to app servers in that segment on specific ports, but nothing else. And that includes traffic flowing to or from the service engines themselves. It enforces microsegmentation.
So preventing lateral movement?
Precisely. It contains breaches. Then you add SpoofGuard. What SpoofGuard does is it prevents a VM, including an SEVM, from sending traffic pretending to be someone else using a fake IP or MIC address. It basically enforces trust at the port level. It ensures that the traffic claiming to be from a specific SE's IP and AMI's address actually is from that SE's virtual NIC.
Ah, okay. So DFW controls who can talk to whom, and SpoofGuard ensures the who is really who they say they are.
You got it. Together, they create a much more robust security posture for that internal east-west traffic involving the service engines. They really complement each other.
And things like, say, IPFIX or GSLB,
Right.
they don't fit here.
Not for this specific purpose, no. IPFAX is about exporting flow data for monitoring or analysis that doesn't enforce security rules. And GSLB, Global Server Load Balancing, That's for directing traffic across different geographic sites, completely different scale.
Right. DFW and SpoofGuard for segment-level security. Makes sense. Okay, last area, troubleshooting. Things inevitably go wrong sometimes, right? And digging through logs or setting up external tools can be painful and time-consuming. Is there a built-in way in Avi for an admin to just capture live packet data directly from a virtual service, without firing up Wireshark on some jump box?
Yes, absolutely there is. And it's incredibly handy. The built-in function you're looking for is the traffic capture tool.
The traffic capture tool. Okay. Tell us more. Why is having that integrated such a big deal compared to, the old ways?
Well, it's a huge time saver and simplifies the whole process enormously. Think about the traditional workflow. You suspect a weird issue with a specific virtual service. Normally, you'd have to figure out which SE is handling the traffic, maybe log into the hypervisor host, set up a port mirror, or try to run TCP dump or Wireshark somewhere that can actually see the traffic, filter it. It can be a real hassle.
Yeah, I've been there. Not fun.
Exactly. The integrated traffic capture tool lets you just go to the Avi UI, select the virtual service you're interested in, define some filters if you want, like client IP, and hit capture. Avi then captures the packets directly on the relevant service engine, handling that VS traffic, and lets you download the capture file, like a PCAP, right from the UI.
Wow, okay. So no external tools needed, no complex setup on hosts.
None. It brings the diagnostics right to your fingertips within the management platform itself. It means much faster problem isolation and resolution. You can quickly see exactly what's happening at the packet level for that specific service.
And this is different from just looking at logs or health dashboards?
Totally different. Real-time logging shows you process log entries, controller events show control plane activities, the health dashboard shows metrics and status. None of those give you the raw packet data. For those times when you absolutely need to see the packets themselves, maybe to diagnose a weird protocol interaction or a TLS handshake failure, the traffic capture tool is the integrated solution. It's a real game changer for operational efficiency.
Well, thank you so much for joining us on the deep dive today. We really hope you picked up some valuable insights into the Avi Cloud Foundation. Hopefully you're feeling a bit more clued in. We'll catch you next time for another deep dive into the fascinating world of tech.